Okay, now for this project, this is going to be an upgrade to the cooling system. We've done this on the Mach 1 about 2 years ago and it really turned out good. We have aluminum radiator and I got a matching shroud for it that bolts to the top and bottom frame of the aluminum radiator. I got 2 electric fans to now mount onto here. The fan kit came with 4 fittings that go down into little keyed slots 90 degrees from each other, and then the fan itself goes on top of the shroud. And in this case here I'm going to use some self-drilling 8 by 1 inch bolts to go into the shrouding and bite, and that will be good for what we need to do. Now, where is that other box? I need that box in here.
The
In order
washers?
to make that plastic box, yeah. In order to make sure these things don't back out, I'm going to go ahead and take the extra measure of putting a small washer and lock washer on these screws. So when they bite into the soft aluminum, I don't have to make it really, really tight, and these lock washers will keep these things from backing out. If ever down the road I find that these things are working loose, which I haven't found on the Mach 1 yet, I'll just put a regular bolt and nut through the things and lock them down. But this has been more than sufficient for these electric fans up to this point. So I'm going to go ahead and do one of these mounts, and then I'll go ahead and do the others off camera. Now I'm not going to use a drill motor, I'm using electric impact. Plenty of speed to do this with soft metal. If there's a steel, I wouldn't be able to do it. And to get this fan on here correctly, I can see the metal shroud through the cage, and so I can see where I'm at all the way around. So I'm going to make sure that it is fairly centered. It does not have to be perfect. And then I'm going to drill in such a manner that this does not go through the aluminum and into the seat. It'll miss the seat. At least it should.
You don't want to hit the seat.
Don't want to hit the seat.
The seat is actually for Syracuse University, but we didn't buy it for Syracuse. We bought it for us for Shelby.
First one's in. Now, for anyone looking, it looked like if I had gone in far enough, this would have cut into my knee. No, actually, if you look at the depth, that screw didn't come down far enough to hit my knee, and my knee was on the edge. So I was not being unsafe with that. Now I am going to take a look on the other side and make sure I have this fairly centered before I finish up with the rest. Sure looks like I do. Okay, I'm happy with that. So I'll do the next one, I'll work my way in. Okay, the rest I'll do off camera. And when we're ready to do the mounting of this and the hydraulic line attachment for the transmission cooler, we'll be back. Well, I got pretty excited about getting this set of fans on the shroud, and I had Linda drag the shroud and the fan assembly over to mount to the radiator frame. I suddenly realized that, by golly, I didn't videotape that. Now that was easy. The other thing we did was we attached high pressure hydraulic hose made for transmission fluid to the steel transmission lines that we had to cut to lengthen. I chose to lengthen the hydraulic hose simply because it's easier to do than using steel with all the flare nuts and all the compression ferrules and all that. I tried that, I didn't like the result, so I went away with high pressure line. This is thicker sidewall and stronger than gasoline or vacuum line. You don't want to use those, they will burst.
But we did flare the ends of
Yes,
the originals.
where I cut the steel lines, I did flare them a little bit to give a little bit of lip, so when we tighten the hose clamps down, they have something to ride against so that the hoses don't pop off under pressure. So meanwhile, the fan shroud with the fans is in place. I'm starting to tighten down the mounting bolts. Now this is boring, so I'm not going to keep recording this. I'll wait until I'm ready to start doing the wiring. But just to catch up where we're at, the radiator, we have the top mounts loose. I'm going to tighten them back down once the shroud is tightened down, and then I'll start working on the wiring. So I'll see you back in a couple of more clicks. With the thermal sensor that will turn the current loose to engage the fan relay, there is a small thermocouple, and it senses the temperature of the coolant. Now, initially I was going to put it in between the cooling fins of the radiator, but it wasn't staying in there securely. So the optional way of doing this is to actually put this thermocouple inside the radiator hose itself, where it will fully engage the coolant. The problem is that the small thermal transfer wiring from the thermocouple itself is now between the radiator metal inlet and the rubber hose. Now in theory, I should be able to tighten this hose down enough to keep coolant from escaping. I don't feel like taking that chance. I'm going to use a small bit of silicone sealer to put this little tube on top of and underneath to provide a better seal, just to make sure that we don't end up having an avoidable coolant leak at that one spot. I'm not going to use this silicone sealer around the entire hose, just in this one area. Now this is both a sealer and an adhesive, and it will adhere to metal, different kinds of metal, as well as rubber. So it should do the job, and because I'm not going to use a whole lot of it, it should also not keep me from getting this apart in the future if I ever have to replace the upper hose or take it off for some reason. So I'm going to get this underneath and above, and then I'll slide this hose right on and tighten it down. I want to tighten this down in such a way that some of this clamping is actually above the tubing. I'm spending doing the wiring for the rest of the thermal switch and for the fan relay, the silicone sealer should be setting up pretty nicely. We will see. I want to push this tubing out of the way the best I can. Earlier, I mounted the thermal switch under radiator support. There's lots of room above here, so these little screw heads are not going to hit the hood. And this rheostat dial will be right where I need it, so I can set the temperature at which this switch lets current flow to the fan relay, which I'll be mounting in just a few more minutes. There's a little excess silicone here I'm going to wipe off. It's not really necessary, but I want to get some of that off of there just because. Okay, you can cut. Each of these electric fans has an electrical lead. They have it from the factory looped with a small wire tie, which I'm going to cut so I can loosen the lead's length. And the installation kit included some extension leads. So I'll plug these in. Now, after the installation is done, I'm going to get some flexible plastic conduit, like right here, to put around the wires to keep them from chafing against any metal objects and to kind of clean things up. So anybody thinking that what I'm doing is going to be the end of the installation, no. I want to get it functional first, and then I'll get it looking pretty and protected. The idea is to make sure there's enough lead on the wires to come up and then over to where I'm going to have the thermal switch and the fan relay mounted. And once I have this done and wired, I'll wire in the rest. Now, the instructions that come with this equipment don't provide a lot of clarity about how exactly this all gets done. So some of this is just seat of the pants. Some of it is from experience with our 73 Mach 1, which turned out pretty darn good, if I say so myself. And in the end, as long as we have something that works and looks pretty decent, I'll be happy. Okay, at this point, we're going to cut. I'll have Linda take another angle and start doing some of the wiring. Well, it might have been selfish of me, but I went ahead and installed the electric fans, wiring, thermal control switch, and relay off camera because it was a little touch and go here and there, but let me recap, and that might help somebody who's looking to do a project like this. If you look down here, you see two connectors. They both go down to the fan, two of them. And from the connector, I use a little wire tie after plugging it into the relay harness. And I ran this down behind the battery through a manufacturer opening. Let me get some light down here. Man, that's tough to see. But through the radiator mount, there is an access hole. I ran the wiring through there. And it wound up inside this conduit tube, plugging into the relay itself. The red wire coming from the relay goes through the radiator support over to here and into a fused circuit. Now I could have put a 20 or 30 amp fuse in here. These same fans on the Mach 1 pull about 17 amps, so I put a 20 amp fuse in, or rather a smaller fuse than a heavier fuse. And from there, I simply tapped into the positive side of an existing circuit breaker. So this is battery voltage, not fuse, not behind a circuit breaker. The circuit breaker protected circuit is the other side. But because I have this fused over here, I'm not too worried about it. So I go from here over to here, fused. And from there, I run it into the relay. Now there's a yellow wire that comes out of that relay. And the yellow wire, I ended up bringing through the radiator access hole, and I connected it into the two red fan wires that go to the two red fans. Now, the fans also have two ground wires. I have those both connected to a little connector here, and I grounded it on the bracket being used to hold the thermal control switch. Now there's an orange wire, a small orange wire coming from the relay, and that will normally go to a thermal control switch. In this case here, that's exactly where it's going. There's three connectors on the thermal control switch, two of which are used. This one comes from the relay. That sends power to the relay when the thermal switch engages. The other part of the relay switch is a ground. And this ground, I simply ran it to the mounting bracket hold down screw for the relay. Simple as that. So basically this relay is being fed from a thermal control switch. I already showed you the orange wire that goes from the thermal control switch to the relay, which triggers the relay to close and send current to the fans. It can handle up to like 60 amps or something like that, a lot more than I'll ever need with this. But the other side of this has to be power going to the thermal control switch. Most folks, including me, will take power from a switched source so that the only time power is applied is if the engine is having the ignition switch in the run or accessory position. Well, there's a downside to that when it comes to cooling fans. When the engine's been running, you come over to a parking spot and you park it. Turn the engine off and all cooling stops. Of course, it would for a mechanical fan anyway. But what I wanted to do was continue cooling even if the engine was not running. So what I did is I took a piece of yellow stock wire, ran it through the radiator support, and I connected it to battery power, the same fused power that supplies power to the high amperage side of the relay. So what that means is anytime the car has the negative and positive battery cables connected, which they are, and I come up to temperature, the fans will come on. Now right now, the fans aren't running because the trigger temperature is too high for that. This is a cold engine. It hasn't been running for almost a week. I'm going to turn this down to a lower temperature, to about 75 degrees Fahrenheit. That's the inside numbers, not the outside numbers. When I do, you'll hear the fans come on. So anyway, that tells me electrically everything is set up. Now what we need to do is finally start the engine. Once it is idling in a stable manner, back it out of the garage so we don't gas ourselves, and wait for the engine to warm up. I'm initially going to set this for 180 degrees Fahrenheit. The thermostat is a 195 degree thermostat. So as it warms up and the thermostat opens, the fans will come on. Once I'm satisfied the fans have come on, I'll probably turn this up to 200, 210 degrees, 205 degrees, something like that, so that when the engine is running 195 to 200, the fans will be off. But if the engine gets warmer because we're not moving faster than 25 miles an hour or we're idling for a long period of time, the temp goes up. The thermocouple sends a signal to the thermal control switch. It sends the power to the relay sends power to the fans come on, cools things down. Thermocouple. Show you what happened here. This thermocouple has a capillary tube that I sent through the radiator mounting bracket out the other side, and I could have put that thermocouple device in between the cooling fins of the radiator. I didn't like that it wasn't being held there securely. There was no tension on it holding it in place. It wasn't going in deep enough. So what I did is, because it's such a thin piece of capillary wire, I ran it inside this cooling hose right about here inside. I used a little bit of silicone to help seal just that part of where the radiator hose attaches to the radiator. So when this warms up, I'll be looking for leaks anyway. I'll be looking there especially carefully. If it doesn't leak, I'll leave it. If it does, I'll figure out a different way to attach that thermocouple in a way that it does the job it's supposed to do. But this is actually the way that the manufacturer suggests making the connection with the thermocouple device. He doesn't mention using silicone. That was me. I just didn't feel comfortable having bare capillary tubing between the hose and the inlet of the radiator itself without being sealed. Okay, we're going to clean up, get this thing fired up outside for the first time in a week. But I say all in all, it's looking pretty good. Our fingers are crossed that I haven't forgotten anything. I'll be checking all bolts and screws one more time, make sure that everything looks good, and then we'll fire this thing up and report back.